All right, ready to explore Comet C 2023 A3.
Absolutely. It's going to be a fun deep dive.
I know you're already interested in this comet, so let's jump right into it.
Sounds good to me.
So, where do we even begin with something like this? I mean, comets, what are they exactly?
Well, comets are basically like cosmic leftovers.
Overs.
Yeah, from way back when our solar system was first formed, like little souvenirs of the early universe.
I like that. So, what's in these cosmic souvenirs? What are they made of?
They're made up of ice, dust, rock, and a bunch of frozen gases all mixed up.
So, kind of like a giant dirty snowball just flying through space.
Exactly.
That's pretty wild. But how are they different from asteroids? They both sound kind of chunky to me.
Good point. It's interesting. While most asteroids are mainly rock and metal, comets have got this big chunk of ice in them.
Oh, I see. So that's what gives them that cool tail as they get closer to the sun.
Exactly.
Yeah.
That's it.
Wow, the tail. Speaking of tails, we got to talk about C 2023 A3, this comet that everyone and their grandma seems to be talking about. What makes it so special?
Yeah.
It's even got a really long name.
It does have a mouthful of a name. And you know what? The name itself actually gives us a hint about its discovery. The C 2023 A3 part tells us that it's a comet that was found in 2023.
Okay, that makes sense. But what about the Suchinshan ATLA's part?
That's the cool part. That tells us that it was actually discovered by two different groups at almost the same time. The Purple Mountain Observatory in China, hence the Suchinshan,
Oh, cool.
and the ATLA system, which is spread out across the globe.
Wow, talk about a team effort. It's like winning a scientific prize together, but on a global scale.
You got it. And you know what? This prize is a pretty awesome one.
Mm-hmm.
C 2023 A3 is really something special for a few key reasons. First off, it's got this incredibly long orbital period, which means it takes forever for it to make one loop around the sun.
Forever, huh? How long are we talking exactly?
We're talking roughly 80,000 years for just one trip around the sun.
80,000 years. Hold on, let me just process that for a sec. So you're saying the last time this thing was visible, humans were still figuring out how to use fire.
That's exactly right. This is seriously a once-in-a-lifetime kind of event.
Okay, that's mind-blowing. No wonder everyone's
Yeah.
so fired up about it. But tell me, is that it? Is it just about the long trip, or is there more to it?
Oh, there's definitely more. It's not just about the long haul. This comet is also predicted to be insanely bright, maybe even bright enough to see with the naked eye.
Wow, seriously.
Yeah. Remember Comet Neowise from a few years back? People were going crazy for that one.
Yeah, I remember that.
So C 2023 A3 is shaping up to be even more impressive, maybe even as bright as Venus in the sky.
Okay, now that is something I would not want to miss. Imagine just looking up and seeing this blazing comet streaking across the night sky, a beacon from the dawn of, well, everything. So for those of us who, want to actually see this incredible event, where should we be looking to catch a glimpse of this celestial spectacle? I mean, I'm assuming we need to know where to look, right?
You're absolutely right, you do. So you're going to want to be looking towards the western sky shortly after sunset.
Okay, westward after sunset. Got it.
Mm.
But will I need like a super powerful telescope to see it? Or will just looking up with my own two eyes be enough?
It might be visible to the naked eye. It really might.
Really?
Yeah.
Hmm.
But using some binoculars or even just a small telescope is definitely going to enhance the experience. You'll get a way clearer view of its structure and maybe even catch a glimpse of its tail as it develops.
Oh, wow. Okay, duly noted. I'll be breaking out my dad's old stargazing gear for this one.
Yeah.
You mentioned the tail developing. That makes it sound like it's like changing over time. What's actually going on there?
It all comes down to all that icy stuff we talked about earlier.
Right, right.
As the comet gets closer and closer to the sun, the heat from the sun actually causes the ice to vaporize.
Vaporize. So it's like turning into what? Gas?
Exactly. It turns straight into gas, and that's what creates that incredible distinctive tail. And that vapor, along with all the dust and other gases, gets blown outward by solar wind, creating those amazing streaks across space.
So it's like the sun is giving the comet a cosmic blowout, creating that tail.
I like that, a cosmic blowout. That's a good one. And what's even cooler is that just observing these tails actually played a really important role in a major scientific discovery. The solar wind itself.
Wait, seriously? Just from looking at a comet's tail, we figured out that the solar wind existed. How did that even happen?
Well, before we could actually, see solar wind directly, and remember, that's a constant stream of charged particles that are constantly coming from the sun. Scientists noticed something really strange about the comet tails.
What was that? What was so strange?
They always pointed away from the sun no matter which direction the comet was actually moving in.
Huh. So it's like the tail knew something that we didn't.
That's a great way to put it. It was this really persistent thing, that outward direction. And it was a huge clue that something was pushing the tail and that something turned out to be, you guessed it, the solar wind.
Wow, that's amazing. It makes you wonder what other secrets are, hiding within these little icy wanderers.
There are tons of them, and every time we learn something new, it opens up even more questions. Studying comets, it's honestly like taking a peek back in time.
The peek back in time.
Yeah, they hold all these clues about what the early solar system was like, giving us this glimpse into the conditions that existed billions of years ago.
So these aren't just pretty lights in the sky. They're like time capsules.
Exactly.
That's incredible. But how do scientists actually extract information from something that's, you know, so unbelievably far away?
Well, one way is by looking at the light that the comets emit. See, different elements and compounds, they all emit very specific wavelengths of light. So by studying those unique light signatures, scientists can figure out exactly what a comet is made of, its chemical composition.
So it's like giving the comet a cosmic fingerprint analysis.
That's a great way to think about it. And just like that, we can start to understand what the basic building blocks of the comet are, and that tells us a lot about what ingredients were present when our solar system was just starting to form.
Okay, that's seriously cool.
Yeah.
It's just mind-blowing to think that something as basic as light can actually reveal so much about the history of the entire universe.
It is. And you know what? Sometimes we get even luckier.
Luckier. How do you get luckier than that?
Remember we were talking about meteor showers earlier?
Yeah, those are awesome.
So remember, those are actually tiny little bits of comet debris that burn up in our atmosphere. Sometimes, just every once in a while, a few lucky pieces actually survive that fiery descent and land on Earth. And those, my friend, are called meteorites.
Wait, hold on. So you're saying we can actually hold a piece of a comet, like, in our hands?
You got it.
That is insane. It
Yeah.
doesn't even seem real.
It's pretty incredible. And by studying these meteorites in labs, scientists can get a super, super up-close look at a comet's actual composition. It's like having this tiny piece of the early solar system, hand-delivered to our doorstep.
Delivered right to our doorstep. I love that. It's mind-blowing to even think about.
Yeah.
That we can hold something so ancient, something that's been traveling for billions of years across space, in the palm of our hand.
I know, it's really something else. And both of these things, the light from afar and the meteorites that we can study up close, they're helping us piece together the story of our solar system bit by bit.
Okay, I have to ask, what kind of stories are these samples telling us? What have we learned so far?
Well, we've learned that the early solar system was kind of a wild place,
Oh, yeah. Wild how?
Well, imagine a place where things are constantly colliding, objects just crashing into each other left and right, everything interacting in this chaotic dance that eventually shaped the planets as we know them today.
Wow, that's a serious mosh pit.
Yeah, you could say that. And comets, because they have this pristine, untouched material from way back then, they give us this amazing glimpse into that early era, They reveal those ancient building blocks and the crazy processes that basically led to our own planet's formation. It's pretty incredible.
That's amazing. It's like they're giving us a front row seat to the solar system's greatest hits. But, we've been talking a lot about comets coming close to the sun, which makes me wonder,
Yeah.
where do these things hang out when they're not, putting on a show for us here on Earth? Like, where do they go?
That's a fantastic question. So these long period comets, just like our friend C2023 A3, they're thought to originate from this distant, really far out region of our solar system called the Oort cloud.
The Oort cloud. Okay, that definitely rings a bell, but to be honest, it's a little fuzzy. Can you, remind me what that is exactly?
Sure. Imagine this. It's like a giant, truly giant cosmic shell that basically surrounds our entire solar system.
Okay, I'm picturing it,
Yeah.
kind of, so it's really far out there, right?
Way out. I'm talking way beyond Pluto, even farther than the Kuiper Belt.
That's really, really far.
Oh, yeah. It's so insanely far away that we haven't even been able to directly observe it yet.
Really?
Nope. But we know it's got to be out there because of the paths these long-period comets take. Their trajectories point right to it.
Wow, that's crazy. So these long-period comets are like, what, travelers from the very edge of our solar system. What even sends them on this epic journey towards the sun after just, hanging out in the Oort cloud for who knows how long?
So picture this. You've got these icy bodies just chilling in the Oort cloud, right? They're just minding their own business, when suddenly the gravitational pull of a passing star, or maybe even the Milky Way itself, just gives them a little nudge.
A nudge, like a cosmic shove.
Basically, it knocks them right out of their comfy orbits and then boom.
They start heading toward the sun.
Exactly. They start this long, slow fall towards the sun, a journey that can take, well, we're talking tens of thousands, even millions of years. It's wild.
Talk about a long commute. But we also have those other comets, the short period ones, right? The
Hmm.
ones that swing by more often, like more than once in a human lifetime. Where did those guys come from?
You're right. Good memory. Those usually hail from a region a bit closer to us called the Kuiper Belt.
Ah, the Kuiper Belt.
It's out there past Neptune's orbit. Think of it like the Oort cloud's more well-behaved cousin.
I like that. So we've got the distant Oort cloud, this treasure chest of long-period comets, and then the Kuiper Belt, a bit closer to home, where those more frequent flyer comets hang out. Our solar system sure knows how to keep things interesting. But with all this talk about where they come from, where they hang out, it really makes you wonder, what's next for comet research? What are scientists really hoping to find out?
Well, think about it. We have these increasingly powerful telescopes and these incredible advancements in space exploration. I mean, we even landed a probe on a comet a few years back, so we're entering a whole new era of comet exploration.
Wait, we actually landed on a comet.
We did. The Rosetta mission, remember? The European Space Agency pulled it off. They landed a probe right on a comet back in 2014.
I can't believe I forgot about that. That's unbelievable. What did we learn from that? I have to know.
It was groundbreaking. We had a chance to get a real close-up look at a comet surface, analyze its composition in ways we never could before, even watch how it changed as it got closer and closer to the sun. It was like having a fully functioning science lab right there on a comet.
That is incredible. It sounds like we're on the verge of unlocking some seriously big secrets that are hidden within these icy time capsules.
I think so too. Every mission, every observation, we're getting closer to truly understanding these amazing objects. And as we learn more, we're getting this whole new perspective on the origins of our solar system and maybe even the universe itself.
It's amazing to think that we can learn so much about such huge questions just by studying these little icy wanderers.
It really puts things in perspective, doesn't it? I mean, this comet we've been talking about, C2023A3, it's been traveling for, what, tens of thousands of years, just silently witnessing the universe doing its thing. And now, just for a little while, our paths cross, giving us a chance to glimpse into its incredible journey and all the stories it carries within.
It really makes you realize that even in something as vast and as mysterious as space, there's always something new to discover.
Absolutely. And who knows what other incredible wonders are out there, just waiting for us to find them as we keep exploring.
Well said. And with that thought, we'll leave you all to ponder the mysteries of the universe for yourselves. Until next time, keep looking up and keep exploring.